The amount of digital information is exploding, literally. Unstructured data, our documents, photos, videos, and other media are growing faster than any other type of data. The amount of information that the average enterprise has to manage today is roughly equivalent to the amount Google managed just 5 years ago. The traditional strategy for managing this information, that of deploying a one-size-fits-all enterprise content management platform, is failing. Built in a different era, they are designed to run on physical servers and use legacy storage components that have predetermined storage limits tied to cyclical hardware purchasing. Even when new hardware is available, downtime for end users is required in order to upgrade. But there is an answer, using Dell EMC Spring Content. With Dell EMC's Elastic Cloud Storage Object Store, you can build your own cloud-native content services quicker than you can with your existing platforms. That will outscale your existing platforms, be more cost-effective, and avoid vendor lock-in. Let's take a look. Here we have a microservice-based document management application. One service provides the user interface. Another service that we will call the content service provides the document management. This service stores the documents themselves and metadata about those documents, renders them into different formats, and answers full text search queries. We'll build this using 3 Spring projects. Spring Boot will provide the server, Spring Data will manage our document metadata, Spring Content will manage the actual documents, provide the renditions, and full text search capabilities. So we start by creating a new Spring Boot project using start.spring.io and importing that into our IDE. We add a dependency on Spring Data JPA on a database client, H2 in this case, and on Spring Data REST. Having done this, we describe the metadata that we wish to store by defining a document class and giving it one field for every piece of metadata we wish to store: ID, title, and author. Next, we define a document repository that extends Spring Data's CRUD repository interface type to document. Spring is opinionated and will use these dependencies we just added with this code to inject a database implementation and a REST service for our documents, meaning we do not have to implement these services ourselves. The same process would apply for any other database, including scale-out NoSQL databases like Apache Cassandra, for example. Now we can turn our attention to document content. To add content storage for our documents, we need 2 more dependencies. As we want to store our content in Dell EMC's ECS, we add Spring Content S3. We also add Spring Content REST. We then return to our document class and add content-related metadata: content ID, content length, and MIME type. Next, we define a document store that extends Spring Content's content store interface. Again, Spring will look at the dependencies we added, at this code, and inject a S3-based implementation of this interface along with a REST service for our document's content. Lastly, we add 2 final dependencies: Spring Content Renditions and Spring Content Solr, that provide our renditions and full text search capabilities respectively. This allows us to modify our document store. We can now extend Renderable to enable rendering document content in other formats. We can also extend Searchable to enable full text indexing and search through an auto-configured Apache Solr integration. Finally, we see a fully working cloud-native, scale-out document management application comprising a user interface service and a backing content service, capable of storing documents and metadata, providing renditions, and answering full text queries, all implemented with just one class, 2 interfaces, and a set of Spring dependencies.